Moving right along with our 5.7 lesson, we now have x to the negative 2/3 power that we're looking at. And again, in this case, we can recognize negative 2/3 as being two different things. It's either negative 1 times 2/3, or we can recognize it as 2/3 times negative 1. If we were to recognize it as the top one, the negative 1 times 2/3, then we would say that we have x to the negative 1 to the 2/3 power, in which case this becomes the reciprocal, 1 over x to the 2/3 power. We can distribute the 2/3 power to each piece individually because this is a division problem, not subtraction or addition, in which case we have 1 to the 2/3 and x to the 2/3. And our properties from before tell us that this is now cubic root of 1 squared over cubic root of x squared. But 1 squared is just 1, and the cubic root of 1 is just 1. So this would be our final answer, except for the fact that it's not simplified. Now before I simplify it, I'm going to show you what happens if we go this way, if we go with the 2/3 and the negative 1. Again, we would say that it's x to the 2/3 to the negative 1 power, which by our properties of power shows that it would be cubic root of x squared to the negative 1, in which case then we have 1 over cubic root of x squared. So we have the same thing in either case. So both are valid ways to get to our answer. You just have to determine which one you like to use more. Now that we have our answer, it is not simplified because we can recognize that we have a radical in the denominator, so we need to get rid of that. And so I'll show you how to do that. We need to multiply by a form of 1, so whatever we multiply on bottom, we also need to multiply on top. Now we can see that we're using a cubic root, so we know that we need to multiply a cubic root. And because it's a cubic root, we want our power in here to become a cube. So since we have x to the 2, we need to make it x to the 3. So we would just use x to the 1, because x to the 2 times x to the 1 will become x to the 3. So we need to make sure that we're multiplying by the same thing on top then. So cubic root of x, or x to the 1. When we multiply these out, 1 times cubic root of x leaves cubic root of x, and the cubic root of x squared times the cubic root of x leaves the cubic root of x cubed. The cube and the cube kind of cancel each other out here, and we're left with the cubic root of x over x. And so in the end, this is our final answer. Moving on to D, because I showed you both ways before, I'm only going to show you just the one way here. So when we recognize our negative 3/4 as our power, we're only going to recognize that as the 3/4 times negative 1, in which case we'd say that we have y to the 3/4 power to the negative 1. From here we say that that will become 4th root of y cubed to the negative 1, in which case here we have 1 over 4th root of y cubed. Again, we can recognize that we're not quite finished here because we have a radical in the denominator, so we need to rationalize our denominator. We know that we are going to be working with a 4th root, because of the 4th root from our denominator over there, and we want to make this power become 4. So we need to be multiplying by a y to the 1st power, because we already have y to the 3rd power. So we need to make sure we're multiplying by both on bottom and on top, or the denominator and the numerator, in which case we're left with a 4th root of y and a fourth root of y to the fourth. Again, the fourth and the fourth get rid of each other, and we are left with the fourth root of y over y. And in this case, this is our final answer. Moving on to simplifying other radical expressions. In these cases, our index is not the same. So we can't just go ahead and take them out of each other because they don't necessarily coincide. So we need to get them into forms that do work. So what we can do is recognize that 16 is the same as, we keep our sixth root, but use 2 to the fourth power. And we have to keep our third root of 2. Now that we have things looking like this, we can change it into our rational exponent form. So we'd say that this is now 2 to the 4 over 6 power. Again, if this is 2 to the 1, we would say over 2 to the 1/3 power. Now from here, we can recognize that 4/6 is the same as saying 2 to the 2/3 power, and again, still over 2 to the 1/3 power. And remember from before that anytime that you are dividing these two together, you are actually just subtracting those exponents. So we would take 2/3 minus the 1/3, those are our exponents, and we're left with the 1/3. So in the end, our answer becomes 2 to the 1/3. Now, we don't want to necessarily keep it like this, so we would actually want to rewrite this back into our radical form. 2 to the 1/3 is the same as saying cubic root of 2. So normally when they ask for these back into the radical forms, this is what we want because we started with a radical. But both of these answers they're equivalent. We just want it in the radical form. Moving on to B. Again, we have the 8th root of 81 and the 6th root of 3. Well, our indexes are not the same. So we have an issue there, but we can change that 81 into powers of 3 because we have a 3 as our radicand here. So we'd say that this is the same as saying the 8th root of 3 to the 4th power and the 6th root of 3, or 3 to the 1st power. Then from here, we'd rewrite it as 3 to the 4 over 8 and 3 to the 1 over 6. 3 to the 4 over 8 is the same as saying, 4 over 8 is the same as saying 1/2, which is also the same as saying 3 over 6. And we would like it to be in that sixth form. So I'm going to rewrite this one as 3 to the 3/6 over 3 to the 1/6. Now once we have it here, again, we can just subtract away these two exponents. So 3 to the 3/6 minus the 1/6 is going to leave us with 3 to the 2/6, which again, we can reduce down to 3 to the 1/3, or how we'd write that is the cubic root of 3. And that one would be our final answer there. Moving right along with these, we now have the 6th root of 4x to the 4th power. Again, it's always a good idea to get these bases down into the coefficients down into smaller bases. So we'd leave the 6th root. We recognize 4 as 2 squared, and x to the 4th would stay. Now we can, again, if we want, we can split it up into the 6th root of 2 squared times the 6th root of x to the 4th. And we can work down from here and say that this one is the same as saying 2 to the 2 over 6, and this one is x to the 4 over 6. in which case, oh, we still have a multiply here. We simplify that down even further to 2 to the 1/3 times x to the 2/3. And since they're multiplying together, but they have the same denominator in their radical exponent, or their rational exponent, we would say that we can take that exponent, or the denominator from that, bring that out, so it stays as 2 to the 1 times x to the 2. And now we rewrite that as the cubic root of 2x squared. So that is our final answer in that case. Move a couple of these over. Looking at D here, again we have the 4th root of 9z squared. Well, 9 we can rewrite as 3 squared, so we have the 4th root of 3 squared z squared. So again, we can break this up if we want, or we can just directly go from the index of 4 and apply it to each of these. So we know that we have, oops, I want that in black, 3 to the 2/4 power and z to the 2/4 power. And from here we recognize that 2/4 is the same as 1/2 in each case. And since they both have the 2, we'd say that we can put it back into an index of 2, which is the same as just saying the square root of, oops, I went black again, 3 to the 1 and z to the 1. Or we can just say the square root of 3z.